This is TK Academy, where the T and the K stand for Team Knowledge for architects and designers. This is a core competency course, which is a back to basics refresher course, and is over the subject of fire resistive construction. Fire resistive construction is a topic that all architects should be familiar with. It is the basis for modern building codes. Within this course, we are going to identify different construction types. We'll explain the differences between passive and active fire protection systems. We're going to explain the differences between firewalls, barriers, and partitions. And we'll identify the classes for flame spread and smoke develop indexes. Throughout history, fire has always been a significant threat to the safety of buildings. The development and adoption of building codes is the resulting solution from past fire disasters. An early fire disaster which led to building codes was the burning of Rome around 64 AD. It was said that Nero played the fiddle while Rome burned, but in fact, the blazing of the city resulted in the adoption of Emperor Nero's master plan, which set forth sound construction principles regarding fire resistance. Much later in history, the Great London Fire of 1644, in which 2/3 of the city burned down, resulted in Parliament drafting the London Building Act, which set forth standards for new construction. In this country, it was the Great Chicago Fire of 1871 that destroyed over 17,000 buildings and ruined a booming insurance industry, which led to new local ordinances being enacted to address construction controls in the prevalent lumber-based industry within the city. In the 20th century, the San Francisco earthquake of 1906 burst gas lines that caught fire in the wake of the earthquake and compounded by the lack of adequate resources for putting out fires. The fire resulted in massive damage to the city, with over 3,000 deaths and 80% of the buildings within the city being destroyed. In more recent times, the MGM Grand Hotel in 1980 was the third worst hotel fire in U.S. history. Vertical shafts allowed the spread of smoke to other levels of the casino. The fire spread through the building due to the lack of sprinklers. 85 people perished from smoke inhalation through the main tower. The terrorist attack on the World Trade Center buildings in 2001 led to the National Institute of Standards and Technology, also known as NIST, to recommend nearly 24 building and fire code changes that were approved by the International Code Council. The changes included codes to increase structural resistance to building collapse, ensure effective communications for emergency first responders, and utilize more robust elevators for emergency personnel. There are two basic principles to fire protection. The first is to contain and limit the spread of fire from propagating to other floors, adjacent areas, and neighboring buildings. The second is to delay structural degradation to provide time for evacuation and response from emergency personnel. Fire-resistive construction and building codes exist to save lives, not buildings. A substantial portion of building codes pertain to fire resistance and delay of fire and smoke propagation. Within the International Building Code, or IBC, there are several chapters dedicated to this. Chapters 5 and 6 limit the height and area of a building based upon the type of construction. Chapters 7 through 9 address fire resistance and protection requirements. The National Fire Protection Association, or NFPA, publishes codes and standards for fire resistance of building materials and performance of active systems. NFPA 1 is the Fire Code, and NFPA 101 is the Life Safety Code, both which have similarity and much overlap with the International Building Code. Other publications by the NFPA apply to standards for fire protection systems and are often referenced by building codes. NFPA 10 is the standard for portable fire extinguishers. NFPA 13 is the standard for the installation of sprinkler systems. NFPA 72 relates to fire alarms and signal code. NFPA 80 sets the standards for fire doors and other opening protectives. And NFPA 92 is the standard for smoke control systems. Building codes set limitations on building height and area based upon the occupancy use classification and the construction type. There are also different limitations established for buildings that are sprinkled and non-sprinkled buildings. The height limitations are defined as the number of stories and the vertical height measured in total feet above grade. The area limitations apply to the floor area or building footprint. Demands for larger buildings, such as hospitals or schools, accompany greater requirements for fire-resistive construction and protection. Building codes do allow for an increase of allowable building area based upon the available frontage. The building code acknowledges the safety benefit of having an open space directly adjacent to a building for access of emergency crews and vehicles, and for the prevention of fire spreading to other buildings. Every building that has access to a public way may increase its allowable building area. A minimum of 25% of the building perimeter must be adjacent to a public way or open space to qualify for the frontage allowance. The width of an open space must be at least 20 feet. The open space must be on the same lot or a dedicated open space, and the open space must be accessed from a street or fire lane. Building code sets out the equation for the frontage increase, equaling the length of the perimeter facing the public way open space divided by the total building perimeter minus 0.25 multiplied by the width of the open space divided by 30. The maximum frontage width is 30 feet. Open space wider than 30 feet does not result in a higher allowance. The frontage increase formula results in a factor that can be multiplied by the allowable building area determined by occupancy used and construction type to result in an increased allowable building area. The construction type will determine the level of protection that is necessary within other parts of the building code. There are 5 construction types that are designated. Type 1 is the most restrictive, requiring the use of only non-combustible materials and the structure having a minimum 3-hour fire resistance rating. Type 2 is also built of non-combustible materials, but it requires a 2-hour fire resistance rating of the structure instead of 3 hours. Type 3 construction is sometimes referred to as ordinary construction. With Type 3 construction, the exterior walls are made of non-combustible materials, and the interior walls can be made of any materials that are permissible by code. Type 4 is considered heavy timber, where the structure is built of heavy timber framing, but the exterior and interior can be made up of any materials permissible by code. The final construction type is Type 5, which is commonly wood frame structures. There are no limitations on the type of materials that are used within a Type 5 building. With the 5 construction types, there is a decreasing level of fire resistance, with Type 1 being the highest and Type 5 being the lowest. There are also designations of A and B, which stand for protected and unprotected, respectively. A protected structure is protected by either sprayed fire-resistant material or being encased within gypsum wallboard. An unprotected structure occurs when the structure is exposed and has no additional protection covering it. Determining the construction type will give direction for the fire resistance ratings of other building components. The fire resistance ratings indicate how long a building component can withstand fire exposure while maintaining its structural integrity. These ratings ensure that building components can provide sufficient time for occupants to evacuate and for emergency teams to respond in case of fire. The fire resistance ratings required for building components depends upon the construction type. These ratings are typically measured in hours and are determined through testing procedures. The various categories within building components are the primary structural frame, bearing walls for both exterior and interior, non-load bearing walls and partitions at the exterior and interior, floor construction, and roof construction. There are exceptions to the given fire resistance ratings required for the listed components, primarily for the roofs. Fire resistance ratings of primary structural frames and bearing walls are permitted to be reduced by 1 hour when they are supporting a roof only and are not supporting other floor levels. The fire resistance rating of structural members shall not be required for roofs that are 20 feet or more above any floor immediately below, such as in tall open spaces like gymnasiums. The code allows the use of heavy timbers where a 1 hour rating or less is required. Finally, an automatic sprinkler system shall be allowed to substitute for a 1 hour fire resistance rated construction, providing such a system is not otherwise required by other provisions of the code. A fire separation distance prevents fire from spreading to adjacent structures, provides safe access for firefighters, and a refuge area for occupants during emergencies. Fire separation distance is defined as the distance measured at a right angle from the face of the exterior wall to the closest interior lot line, the center line of a street or alley or public way, or to an imaginary line between two buildings on the same property. Fire protection systems will either be considered passive or active systems. Both types of systems are crucial and work together to provide a comprehensive fire safety strategy. Passive systems are that which the fire resistance is inherent to the physical material or construction of a building. Resistance can be augmented by applications of materials such as protective spray membranes and fire sealants. Active systems are those that respond to fire or smoke events such as fire suppression sprinklers, smoke detectors, and alarms. Active systems can be manual or automated. A key difference between passive and active systems is that passive systems focus on containing and slowing the spread of fire, while active systems aid to detect and suppress fires. Fire-resistive construction is the property of the materials or their assemblies that prevents or retards the passage of excessive heat, hot gases, or flames through a structure or space. Construction materials are distinguished between non-combustible and combustible. Non-combustible material is something that will not ignite, burn, support combustion, or release flammable vapor when subject to fire or heat. Non-combustible materials are concrete, steel, and masonry. Combustible building materials are woods and plastics. Resistance is measured in the general indication of the amount of time a material can be subject to fire or heat before failure. It indicates the available amount of time for evacuation, firefighting, and emergency response while under a fire condition. The building code is concerned with the fire resistance of structural members, for how long a building can remain before it begins to have structural failure and face potential collapse. The fire resistance rating of structural members must comply with the requirements for the construction type. When the building's structural framing requires additional protection, it is often done with sprayed fire-resistant material, or SFRM. The fire resistance rating depends upon the minimal thickness, the dry density of the spray material, the application method used, the substrate material, and the spray material's physical properties. This is a tested product that will determine the fire resistance rating that can be applied to the structural system. Fire protection coverings must be protected from impact damage. Otherwise, the fire protection of that structural member could be compromised. The code prohibits embedding pipes, wires, conduits, ducts, and other service facilities that cannot be embedded into the protective coatings of the structural framing. The notion is that penetrations through the fire protective coating can conduct heat and compromise the fire resistance of that component. Exterior walls may or may not have fire resistance requirements. The fire resistance rating of exterior walls is dependent upon three factors: the occupancy use classification, the construction type, and the fire separation distance. The fire separation distance is measured in increments up to 30 feet. There are no fire resistance rating requirements for exterior walls when the fire separation distance is 30 feet or more. When the fire separation distance is less than 30 feet, the extent of the fire resistance rating of the exterior wall is dependent upon the occupancy use classification and the construction type. The fire separation distance is measured from the exterior face of an exterior wall to the lot line. However, it is permissible to have projections that extend into the separation zone. Types of projections would include balconies, overhangs, and cornices. The extent of the projection depends upon the fire separation distance. When the fire separation distance is 2 feet or less, no projection is allowed. With a fire separation distance of 2 to 5 feet, a projection is permissible up to 24 inches from the lot line. For a fire separation distance 5 feet or greater, a projection is permissible up to 40 inches away from the lot line. When it is required that the exterior wall has a fire resistance rating, it is also required that the wall has a parapet, unless the exterior wall terminates to the bottom of a fire-resistant rated roof assembly. Parapets shall have the same fire resistance rating as the exterior wall, and they shall extend a minimum of 30 inches above the roof plane. Exterior walls that have a fire resistance requirement may have a maximum allowable area for wall openings, which include windows and doors. The maximum area of openings in an exterior wall is dependent upon the fire separation distance. When the fire separation distance is 30 feet or more, there are no limitations on the amount of openings for the exterior wall. When the fire separation distance is less than 30 feet, there may be limitations on the amount of openings, depending upon whether the structure is protected or unprotected, and if the building is sprinkled or non-sprinkled. Fire separations within a building are meant to contain a fire and keep it from spreading to other areas. Fire separations can be done with firewalls, fire barriers, and fire partitions. Firewalls are the most stringent, and they are used to separate occupancies. It is a continuous separation that extends through the building structure. Firewalls extend through exterior walls by 18 inches and through roofs by 30 inches. With firewalls, there must be structural redundancy on both sides of the separation, so that if one side collapses due to structural failure, the other side can remain standing. Firewalls must be made of non-combustible materials, and they have 2 to 4 hour fire resistance ratings. Openings within firewalls cannot exceed 25% of the wall area. Fire barriers separate egress routes, vertical shafts, and incidental uses within a building. It is a continuous separation that extends through the building levels from foundation to roof. Fire barriers can be made of any material permitted by the code, but are typically made of non-combustible materials. Fire barriers will have 1 to 4 hours fire resistance ratings. Openings shall not exceed 25% of the wall area. Fire partitions will separate corridor walls and tenant spaces within multi-occupancy buildings. It is a continuous separation that goes from the floor to the structure above. Fire partitions do not extend through the structure. Fire partitions can be made of any material permissible by the code and are typically rated from 30 minutes to 1 hour. Similarly, a building can have smoke separations that are meant to compartmentalize smoke and keep it from being transmitted throughout a building. There are smoke barriers and smoke partitions. A smoke barrier separates smoke compartments, such as an elevator lobby and refuge areas. It is a continuous separation through the building levels from foundation to roof and will have a 1 hour fire resistance rating. Note that a smoke barrier is a 1 hour fire resistant barrier, but a 1 hour fire resistant barrier is not a smoke barrier. Smoke partitions are necessary to prevent the passage of smoke. It is a continuous separation from floor to structure above and does not extend through the structure. Smoke partitions do not have a fire resistance rating. Fire-resistant floor and roof assemblies are meant to keep the fire and smoke from moving from one level to another. Note that not all floors and roofs are required to have a fire resistance rating. The fire resistance rating of a floor or roof is based upon the construction type. When a floor or roof is required to have a fire resistance rating, assemblies must be continuous without any openings. The supporting structure of the floor or roof assembly must also include fire resistance protection at the same rating. The goal is to prevent propagation of flames and smoke from one level to another. However, vertical openings between 2 stories that are not concealed with the construction are allowed. When the vertical opening is more than 2 stories, it is considered an atrium and is subject to other code requirements. Shafts are enclosed vertical connections between openings through horizontal assemblies such as floors or roofs. Shafts are common in buildings, especially with stairwells and elevators, but also with chases for mechanical ducts and piping. Shafts are constructed as fire barriers. When the building is 4 stories or less, the shaft can be a fire barrier with a 1 hour fire resistance rating. For buildings that are taller than 4 stories, the shaft must be constructed of a 2 hour fire resistant rated fire barrier. Vertical shafts throughout a building must have enclosures at both the top and the bottom of the shaft. The bottom of the shaft can extend to a floor assembly with the same fire resistance rating as the shaft, or the bottom of the shaft can terminate to a room having a similar use or function if the room maintains the fire resistance rating as the shaft. A good example of this would be an elevator that has the elevator equipment room on the lower level. The elevator equipment room must maintain the same fire resistance rating as the vertical elevator shaft. Likewise, shafts have enclosures at the top of the shaft. The top of the shaft can extend through the roof assembly to the exterior. It can terminate to the bottom side of the roof assembly that has the same fire resistance rating as the shaft, or the top of the shaft can terminate below the roof assembly and be enclosed at the top with a construction of the same fire resistance rating as the shaft. A common example of this would be a mechanical chase that extends through the roof and terminates inside of a mechanical penthouse. The goal should always be to minimize penetrations through fire-resistant assemblies, but penetrations will happen for building services. When penetrations do occur, the penetration must be treated to the same level of protection as the assembly. Penetration fire stopping systems have a tested performance. A Type F rating means a time period that a through penetration fire stop system limits the movement of fire through an assembly. A Type T rating applies to any penetration, and it measures how long it will take to raise the temperature of an assembly by 325 degrees Fahrenheit on the opposite side of that assembly. A Type L rating applies to air leakage for penetrations of smoke barriers. Another consideration to limit the spread of fire and smoke is through joints and voids within a fire-resistant assembly. There will be joints between walls, ceilings, roofs, penetrations, and openings, and there will be voids and spaces in constructed components. Joints installed in or between fire-resistant rated assemblies must be protected by an improved fire-resistant joint system designed to resist the passage of fire or smoke for a time period not less than the fire-resistant rating of the wall, floor, ceiling, or roof assembly. The material that is used to fill annular space within construction shall prevent the passage of flame and hot gases, such as mineral wool. The type of joints that are commonly identified with fire-rated joint sealant systems are head of wall, bottom of wall, wall to wall, floor to floor, and floor to wall joints. Openings within fire-rated systems are a special concern to limit the spread of fire and smoke. Opening protections include doors and windows. A door within a fire-resistant wall assembly must have a fire resistance rating according to the appropriate level of the wall assembly rating. Typical ratings for doors are 20, 45, 60, 90, and 180 minutes. Doors within corridors or smoke barriers will have a minimum rating of at least 20 minutes. Fire-resistant rated doors must be latching and have automatic closers. Door seals must be installed on the door frame to keep the transmission of smoke from passing through the door opening. Fire-resistant rated doors must have a factory label affixed that indicates the rating level. This label is typically placed on the hinge side of the door edge. Doors will often include vision panels. Vision panels are permitted within fire-resistant rated doors, but the maximum size of a vision panel is 100 square inches, unless the glass and door have been tested for a higher performance rating. Fire partitions will sometimes include interior windows. Interior windows are not permitted within the use of fire walls or fire barriers. Interior windows are allowed in fire and smoke partitions when the window has an appropriate fire resistance rating based upon the wall assembly rating level. Common examples of these are 20, 45, and 90-minute ratings. The glazing within the window must have a fire protective rating or fire resistance rating. Fire resistance glazing blocks radiant and conductive heat to provide a higher level of protection than glass with a fire protective rating. The total area of fire protective glazing in a fire resistant wall assembly shall not exceed 25% of the total wall area. In addition to doors and windows, there will often be ducts and air transfer openings within fire-resistant wall assemblies. When this occurs, a damper must be used. A damper is a device installed within the ducts or air transfer openings designed to close automatically upon detection of heat and resist the passage of flame and smoke. There are three types of dampers: fire dampers, smoke dampers, and combination fire-smoke dampers. Duct penetrations through fire and/or smoke-rated wall assemblies must include a damper with an equal level of protection rating. Fire can also propagate through the concealed spaces of a building. This is especially concerning in combustible construction. Within concealed spaces, there are two methods used to mitigate the propagation of fire and smoke. The first is with draft stops. A draft stop is a material or construction that is installed to restrict the spread of fire and smoke within a concealed area. Commonly, these draft stops are used in attics and crawl spaces. Draft stops are not considered fire-resistant rated assemblies. They limit the amount of open space within a concealed area. Within a floor or crawl space, the maximum area allowed between draft stops is 1,000 square feet. In attic spaces, draft stops must be installed so that there is no more than a maximum of 3,000 square feet between draft stops. Fire blocking is a material, typically within combustible construction, which prevents the rapid propagation of fire within a framed cavity of a wall. Fire blocking is required at the floor and ceiling levels to keep fire from spreading between floors, and at vertical intervals no greater than 10 feet. Although construction methods limit the spread and propagation of fire and smoke to different areas of a building, the interior finishes and materials can propagate fire and smoke within a space. Products and materials are measured by a flame spread and smoke developed indexes, which are determined by testing according to ASTM E84. A flame spread index is an indication of how fire can be spread through the combustibility of certain materials or products. Similarly, a smoke developed index is the indication of how much smoke is produced by the burning of a particular material or product. Building codes divide materials into three categories: Class A, B, and C for levels of flame spread and smoke developed indexes, with Class A being the most stringent and Class C being the least. The flame and smoke indexes are applicable to all interior finishes, trim, and decorative materials that are installed within the space. The type of materials that can be installed are determined upon the occupancy use classification of the particular area and if the building is sprinkled or non-sprinkled. All materials and systems that are used for the fire prevention and smoke mitigation on a building must have confirmed performance testing. The American Society of Testing Materials, or ASTM, is the center that governs the testing of construction materials and elements to determine adherence to fire resistance rating requirements as dictated by building codes. There are multiple different tests depending upon what standards are being met, but the common ones referenced by building code are ASTM E84, which is the standard test method for surface burning characteristics of building materials; ASTM E119, which is the standard test methods for the fire test of building construction and materials; and ASTM E2859, which is the standard test method for ignition characteristics of finished textile floor covering materials. This concludes this TK Academy course over fire-resistant construction. If you enjoyed this course, give us a thumbs up and please leave us a comment. Remember to subscribe to our YouTube channel for more courses and other content from TK Architecture.